Hello everyone. This presentation is going to discuss a snapper design using composition over inheritance using behavior objects. In it, I will go over what makes a system compositional, a traditional approach to a snapper, define what behavior means to me, and give a few examples of behaviors that exist today in CM. I will also provide the trade-offs of such an approach and a way to compositionally construct the same snapper that I will show traditional hierarchy to. I will also show how to safeguard against the drawbacks of composition. And by the end of the presentation, my hope is that you will be able to see how snapper could be set up to use composition successfully. But first, I will introduce myself. My name is Keo Bayo'o, for those that have not met me. That's pronounced I-yo-o. I've lived in Grand Rapids for 13 years, and I moved here after getting my bachelor's degree in computer engineering from Purdue University. My then fiance, now wife, moved with me to Michigan, and we have two kids who keep us pretty busy. Among some of other things listed in no particular order, I enjoy coffee quite a bit. I also enjoy gaming, like I assume a lot of you do. And I am unfortunately not able to play as many games as I'd like today, but um, it is what it is. Professionally speaking, I started working with Configura when I moved here 13 years ago. This block P is actually something I did in my first month in exercise and graphics. With the exception of a few one-off R&D initiatives, I have worked most of the time with the then production team, which is now what we call the customer delivery team, creating extensions for all of the current industries we have today. So what is design by composition? What I mean is designing with composition over inheritance. Some refer to this as the composite reuse principle. But hopefully this is nothing new to those of us who have gone through a CS course or two. But as a refresher, the definition is on the screen. And the part that I want to highlight is the behavior and code reuse by their composition, by containing instances of other classes that implement the desired functionality over inheritance from a base or parent class. What we will be covering in this is how we can achieve this with a snapper in CM. And I may time to time just shorten this to simply composition. But first, a demo. So here we have a few different examples. I have this triangle snapper, and I have this cylinder snapper. They can do a few different things. While I am demoing this, think about how the hierarchy for a common base class would be set up for these two snappers. So on this circle, it has a collision, and if it is within this outer collision bound, you will see that the collision message says the shapes are too close. And if I move it away and refresh, the collision actually is no longer valid. So, pretty simple snappers. They have their dimension shown. This one has a collision quick property, this one does not. They can also generate parts for themselves. Get that out of the way. You can see that they are creating their own parts. So not much to these guys, right? So as I was demoing that, I asked what would be the hierarchy of those two snappers that I demonstrated. Um, Traditionally speaking, that is. So traditionally, we would actually have one snapper base class, let's say simple shape snapper, and it would have two children, one for the triangle and one for the circle. Now, when we talk about methods to override in each of these classes that were shown in the demo, what comes to mind for that? I've listed a few that had to get overwritten to achieve the functionality that we saw. The first one would be get 2D, get 3D, draw features, user property change is another one, visible in properties, append validations, and get parts. These methods would all have to be overridden in the leaf classes in order to achieve what we saw. Notice that these methods only have one common thread between all of them, and that is that they exist on a snapper. So if we were to try and group them by functionality, we could create 4 different groups, one for the graphics, one for the properties, and then one for each of the invalidation and the parts. Now, so what if we could simplify things even more? This example is actually pretty simple as it is, but a lot of our hierarchies go much, much deeper than this one. So what if we could take that hierarchy and get it down to maybe a single snapper? The definition of composition, as I highlighted before, mentioned that the instances of other classes were used to implement the desired functionality. So if we have an object that could do the things that Snapper can do, like the graphics, the properties, the invalidations, and the parts, like we highlighted in the previous slide, then we could use those objects instead of having an entirely new Snapper for each variation that we wanted to achieve. If we wanted to draw it differently, or if we wanted it to snap differently, we would then have the ability to simply swap out what I refer to as behaviors, along with other programming languages. I know Rust refers to them as behaviors. We could scope these behaviors such that maybe only they touch a single piece of what makes a snapper a snapper. And down in the bottom part right here, there is an example of how the behaviors could be iterated over, given that they were in a collection. And it would call the, I guess, parity method within the behavior to grab that, in this example, part out of each behavior that would supply it. So my definition of behavior has been put on the screen, and that is a behavior is an object in a composition-favored approach which encapsulates specific functionality or functionalities. To rephrase a bit, a behavior is just an object that does one or many specific things, the key point being specific. The code on the screen is actually the snapper behavior that I created for those 2 snappers that I demoed earlier. And then the derived classes of the behaviors would override the grouping of methods to encapsulate a particular aspect of the snapper. For instance, a graphics behavior would particularly override these 3 here, the get 2D, the features, and the 3D, and then that's all it would do. The behavior must remain small in scope for this pattern to work successfully. Um, Historically speaking, we actually have quite a few behaviors in our code. Um, and in the past, I have seen these kind of objects referred to as environments or envs. I have even written such things as envs. But I think in terms of naming, behavior fits this a bit better. So I sort of alluded to the fact that behaviors aren't exactly a new concept to CM. We have a few long-standing examples in all of our abstracts and actually within core. The first one in core that I'll bring to the screen is the snapper animation behavior, spelled a bit differently than what we do today, because I think it's from our English UK localization phase. Um, but the animation behavior encapsulates the various animations that can be created by the snapper, the drag, the insert, the favorite, and so on. And that is so we can simply swap out the animation behavior. Another one that you might not know or even think of as a behavior just because it's named um, counterintuitively, I think, from a behavior is the panel junction in the commercial interior abstract office. Um, and I say it's a behavior because it captures the 2D, the parts, the connections, all the things that make a snapper. Um, and when we swap out a panel junction, the only thing that changes is the panel junction and not the snapper itself. So for the material handling developers that are watching this, I put on the screen a picture of some panel frames connected together, and the red highlights are what I'm referring to in the panel junctions. There's actually a panel junction snapper in between the frames, and the panel junction is what drives the parts and connections and so on. And then the more formalized behaviors that we have today are the kitchen and bath, K2 specifically, and the material handling behavior. And these behavior objects encapsulate almost all of the snapper methods today. There's actually very few methods that aren't covered by these classes because we have taken a design by composition approach for these two abstracts. So now you may be wondering to yourself, why? Why make things more complicated? Um, wouldn't this be more complex? And the answer is yes, it would be more complex. Um, but before we get into the benefits, I do just want to get some of the trade-offs or the drawbacks right out of the way. And the first being complexity. Yes, there are more classes, and those behavior classes could cause possible contradictions. Um, there is an increase in boilerplate overhead, right? Each of the methods that I showed in the behavior code earlier does require you to pass in the owner. And what was once just a method override on a leaf class now becomes an entirely new class with a method override, right? So yes, there is boilerplate code overhead. And then performance cost. If I'm creating a bunch of these objects, what does that do to my memory footprint? And if I'm iterating over all of these objects for every call, what does that do to my performance? So yes, there could be a performance question as well. But I think one of the bigger drawbacks that I see is it changes the way we have to program. The traditional OO example of an animal, right? You have an animal, and then you have a four-legged animal, and then you have a dog, and then you have, I don't know, a Shih Tzu, right? That thinking doesn't necessarily translate one-to-one to a design pattern. So we have to think more in terms of behaviors than a strict hierarchy. So yes, it will change the way we need to program. But I do believe that there are a lot of benefits to this approach, especially in a system like ours, where I have seen, 20 levels to snapper in an extension. And I would argue and wager, I guess, that there's probably more than that out there in extensions that I haven't maybe seen. But the benefits that we get from design by composition, um, the first one that I'll talk about is encapsulation. It allows us to um, reuse a lot more. And especially if we can create a stateless behavior. What I mean is a behavior that doesn't have any fields on it, any state, one that we can create a lazily loaded constant for. Um, that can live as a single instance and, it addresses the performance memory footprint question in itself. Um, and it also decreases the garbage collection time if I'm throwing away a behavior, so it just lives on as a single instance and decreases the memory usage. um, and it allows us to focus in on smaller classes. There are classes out there that you've maybe seen break the line limit, right? Um, if we could break those up into separate objects and apply a behavior pattern, then we can actually focus in on specific aspects of a behavior within a snapper and avoid, such large files. We can also avoid this fragile base class problem. Um, Overriding snappers becomes completely unnecessary. Um, That's the double-edged sword, though, of the boilerplate code. But because of our deep hierarchies, um, we, especially at Configura, need to be extremely careful when we go in and we edit, um, at the core level, snappers, and all of those objects that the extension inherits from. Um, some of them haven't been touched just because we're not sure, who it will affect. So this question of the fragile base class problem becomes completely sidestepped. Um, and finally, what I believe is the biggest benefit is flexibility. Objects, the behavior objects, they can be added or not added depending on what you want. If you don't like it, you don't need it. If you um, still don't like it, that you can't maybe live without it, just add your own. You replace it. Um, but I think one of the bigger um, benefits to having this approach is giving power to the users. If we can develop the correct UI for um, swapping behaviors, then we can place users in control of functionality. And I think that will be one of the biggest wins. And I will demonstrate just that.
So we have our two simple shapes still. Um, they behave the same exact way as I demoed earlier with collisions and all of that stuff. But here's where things can get a little more interesting from a user and even a developer perspective. Um, I have this debug behavior dialog that I created um, that it shows the available package scoped constant behaviors at the bottom and the selected snappers behaviors that exist on it. If I change the selection, you can see this has a triangle parts and that pop-up menu behavior that appears when I right select. Um, and this has the collision, which if didn't notice, the quick property only is available for those that have collision. It also has an additional feature, behavior. So say, for example, a user wanted to only show collisions with like objects. Um, they could potentially come in and change how it behaves. So now if I have this, you can see that they collide with one another. But if I bring in the triangle, it's still just this one that is colliding with the top one. If I delete this guy, you can see that there's nothing to report colliding for. So you can kind of get the idea on how this could be leveraged for users to interact with particular behaviors. Um, Normally, this approach would require you to create some if-then logic around, maybe an enum or, the class type or something like that. But this is simply a um, different class that behaves differently. Parts, for instance, could be altered too in this way. Or um, you can imagine, say, a user needs, uh, no parts because they've already ordered it and they're in a different phase, but they just want to account for it. We could add behaviors to particular snappers that would allow us to know without area tag or some other function that this piece shouldn't generate parts. It's only there as a reference. Um, a normal functionality for something like that would require, some Boolean quick property perhaps that would be turned on or off, or like I said, area tags that we would then have to check against. Um, this allows them to generate parts or not, just based on whether a behavior is there. A user could also control what appears in the pop-up menu. So if I had maybe a different level of user, maybe I had a brand new user to CET, we could design it in such a way that not all these options appear, and then as they progress in their career, they could be opened up to new behavior, new functionality that could be behind a channel even. So there's a lot of possibilities for creating flexible behavior and user experience in this approach. And just to round it out, we've been talking about that graphics behavior for a minute here. So they are in fact all the same snapper, right? Um, so I can now make this one a star and this one a star, or turn this one into that triangle, this one back to the cylinder. So there is plenty of opportunity for user-based flexibility in addition to programmer-based flexibility.
So you're probably asking, all right, how do we get there then? How do we program this? And I'm going to outline a few different things here. The first one that we need is a parity behavior object. By parity, I mean the snapper's method should look in signature a lot like the behaviors, and the snapper should be passed into that method as well. And all of the snapper's methods um, that make a snapper should be covered. Um, so yeah, that's the first part. The second part is kind of self-explanatory. The snapper just needs to have a behavior collection field. And then the snapper override methods, um, so all of the methods that you put into the behavior object are now being called by the snapper itself. And we will use the behavior version instead. In some instances, you might be able to create like a graphics behavior that you can call explicitly. Um, well, actually, that might not be a good example because you might want multiple graphics behaviors. So there are some optimizations that you could do, um, you know, to get the explicit behavior that you're looking for in a particular method. And then this next one I haven't really talked about. So what happens to the identity of the snapper if it all gets, um, you know, uh, put into behaviors? If I only have one snapper within my extension, how do I know that this snapper, say, is a chair versus a table? Um, that is where another object kind of comes into play, and it should be the state holder. This is the identity. This keeps the values that are unique to its form, borrowing a bit from Aristotle here. Um, this is what I called the object that lives on the simple shape snapper, is the snapper form. And what this object does, this houses the dimensions. It houses, um, you know, the information that makes it unique. For example, width, depth, and height. And then the final thing that we'll need to create is the spawner. Snapper spawners, hopefully you're familiar with them. This is what adds the behaviors to the snapper on creation. So this is extremely important to the design by composition process. We also get an added benefit from it of creating snappers in different ways. So we could create, um, for example, a snapper that has a collision behavior and one without. It could be the same snapper and form. So now that we have a approach on how to programmatically apply a design by composition to a snapper, let's talk about how can we prevent all of those drawbacks, or at least mitigate some of those drawbacks that we talked about earlier. The first one is that complexity piece, addressing complexity. Um, complexity can be approached by ensuring that behaviors on a snapper have unique purposes, um, and that can be denoted, say, with a key. Um, keeping them unique, um, allows both the programmer and the computer to know what that behavior is there for, to detect duplicates, those kind of things. This further strengthens that piece of having a well-defined purpose for a behavior. Also within them, you know, keep the like functions grouped, like we talked about. The graphics behavior, just doing the graphics. Um, the next point is keeping the behavior simple, but avoid small, trivial behaviors. So balancing between too small and too monolithic really depends on the domain and the scale of your particular object, but I would recommend start breaking down the responsibilities um, based on, like the single responsibility principle. Um, keep the behaviors cohesive but not too granular, because overly small components can increase complexity. But the monolithic objects reduce flexibility. So trying to find the balance can be a bit tricky at times. But I think if you limit what your behavior object does to, say, the grouping of the snapper, then it probably shouldn't be much of an issue. Um, and also, if you are transitioning from an existing inheritance system, go gradually with the behaviors. Naming becomes even more important because a good class name is going to help broadcast that behavior's purpose and solidify to the developer what it's supposed to do. And then this one is referred to as Kernighan's law. So debugging. Debugging is twice as hard as writing the code in the first place. Therefore, if you write code as cleverly as possible, you are by definition not smart enough to debug it. And this particular design pattern does provide quite a bit of cleverness. So that means our debug tools need to be improved. You need to create, you know, more robust debugging tools. That behavior dialog that I showed is actually one such tool in the demo before this. So let's talk about performance. The behavior lookup should be as fast as it possibly can, especially if you're looking for a specific one. Say I'm looking for all my graphics behaviors. That should be as fast as it can be. And removing state, for instance, removing state will decrease the memory footprint, like I talked about earlier. And then addressing the boilerplate. We're all programmers, hopefully. Automate as much as you can. There is that one-time expenditure for creating a snapper that uses a behavior approach. But beyond that, make syntax, create aliases, and so on. If it's repetitive enough, make a script even. If you use Emacs, YA snippet is actually pretty good at creating snippets of code. So use the tools at your disposal to generate the boilerplate for you, so then that way you're not spending that time trying to create it yourself. So, in conclusion, hopefully this has been an informative, practical approach to achieving a design by composition pattern for your snappers, and at least hopefully get your head thinking about such an endeavor. Maybe even makes you want to transition your existing snappers to this way. But the main takeaways that I want to highlight are the composition over inheritance provides through modular design and encapsulation of behaviors that both the users and developers benefit from an enhanced customization and simplified maintenance of our software. So, thank you for listening. I hope this has been informative, um, and hopefully you can take away some things from this. But if there are any questions or you would like, maybe even further discussion around um, what or why, this sort of pattern could be good for your extensions, then feel free to contact me at my email address, um, which I also included a QR code to that effect as well.